Right, so here we're going to be looking at mutually exclusive events. Now, just to summarize what mutually exclusive means, we know that probability can go on a scale from 0 to 1, and we can think of anything in between as a fraction or as a decimal or whatever we like. 0 would be an impossible event, and 1 is something that's certain. If I tell you that the probability that I do a certain thing lies about here, let's say that that's a third, then the probability that I don't do that thing is everything else, which means it would be 2/3. And really, that's a summary of what we're talking about in this video. So mutually exclusive events, mutually exclusive means they can't both happen together. So the probability that I get a heads, for example, when I flip a coin is a half, and the probability that I get a tails is a half. And you may notice that those two things add to make 1. Now, in fact, if I'm listing every possible outcome of something happening, then they will always add up to 1. So we often talk about a bag that's got some balls in it. So if I tell you this one's going to have 3 purple balls in it and it's going to have 4 red balls in it, then the probability that I pick red, we've already seen, would be 4 out of 7, because there are 4 red balls and 7 balls altogether. And the probability that I pick purple would be 3 out of 7. And those things add to make 1, because they encompass every possible outcome when I pick a ball from that bag. Now, the same is true if we're dealing with decimals as well. If I tell you that the probability that I win is 0.2, the probability that I draw is 0.4, then we can work out the probability that I lose, because those two probabilities together so far make 0.6. So what's missing from 1, if I've already got 0.6, so what must the probability that I lose be? Well, 1 take away 0.6 is 0.4, so that's the missing probability. It must be 0.4. Here's a couple of questions which sort of demonstrate that idea. If you want to get a bit more of a handle on things, you can just leave the video playing as I talk through, or alternatively, you can give these a try if you want and then listen to my explanation afterwards. So the first question, the probability that a student in my class has brown hair is 6/11. So the probability that they do not have brown hair is the rest of the probability. So it's the rest of the 11ths. 6/11 is the probability that they have brown hair, as it says in the question. So how many other 11ths are there? That's 6/11, so 6, 7, 8, 9, 10, 11. So there are 5 11ths unaccounted for. That's the rest of the probability. So that's the probability that it's not brown. We then have a decimal. We have a table with decimals in it. Complete the table. We've got the probability that they win and that they draw, and we need the probability that they lose. Well, so far, we've got 0.35 and 0.4, which is a total of 0.75. So what does the lose probability have to be so that they all add up to 1? Well, another way of thinking about that is what's missing from 0.75 to make 1, and the answer is 0.25. So that is the probability that they would lose. And that's mutual exclusivity. It's basically just the property that if you're listing all the possible outcomes of an event, they have to all add up to 1. And you'll occasionally be asked to find a missing probability based on that fact. That's mutual exclusivity. Hope that helps.